Student, 6th grade physics for distinguished schools, chapter 2 electromagnetic, lecture 2. Assist teacher مثنى المولى master's degrees in physics of remote sensing. مرحبا بكم أبنائنا طلبة الصف السادس العلمي لمدارس المتميزين في درس جديد من دروس مادة الفيزياء، الفصل الثاني، الحث الكهرومغناطيسي، المحاضرة الثانية. فأهلا وسهلا بكم. If the positive particle moves with a velocity perpendicularly on the lines of uniform magnetic field, what happens in this case? In this case, it will be affected by a magnetic force is perpendicular on that flux. The particle will deviate from its original path. It will flow a circular path because the magnetic force affects perpendicularly on the velocity vector by the relationship magnetic force equal charge multiply cross product between velocity and magnetic flux density. Then we can retain the equation for magnetic force equal charge multiply velocity multiply magnetic flux density multiplied the sine angle, where this angle between the velocity vector and the magnetic flux density vector. From this figure, when the positive charge moves inside the uniform magnetic field, perpendicular moves in magnetic flux density or magnetic field, the line of the magnetic field start from the North Pole to the South Pole. When this particle inside this field affected by the magnetic force, this magnetic force perpendicular in two-path plane contains the velocity of this particle and the magnetic flux density. How can you determine the direction of the magnetic force? By using right-hand rule. The right-hand rule represents the right-hand fingers rotate in the direction of velocity towards the magnetic field. So the thumb points represent the force direction of magnetic force. There are some notice is very important. Number one, magnetic force always affects in perpendicular direction on the plane which contains both magnetic flux vector and velocity vector. Number two, the effect of the magnetic force on the moving negative charge is opposite the magnetic force, or the opposite direction of the magnetic force which affects the positive charge. Now, show this figure. When the positive charge, the magnetic force, the up direction. When using the negative charge from the right-hand rule, the direction of this force down Number 3, to calculate the magnetic force, this relation applied magnetic force equal charge, velocity, magnetic flux density, and find the angle between the vector velocity and the vector magnetic flux density. Number 4, magnetic flux density units in the international system of units equal Newton divided the ampere multiply meter. Called this unit Tesla supplies by letter capital T. If the velocity vector is parallel to magnetic field or magnetic flux density vector, calculate the magnitude of magnetic force. When the vector velocity parallel the magnetic flux density, the angle will be equals 0. Therefore, the sine 0 equals 0. Then no magnetic force is created. In this case, magnetic force equals 0 from using the relationship magnetic force equal charge, velocity, magnetic flux density multiply the sine angle. Angle equals 0, sine is 0 equals 0. In this case, no magnetic force. Now question, if the velocity vector is perpendicular to the magnetic flux density or magnetic field vector, calculate the magnitude of magnetic force. In this case, when the vector velocity perpendicular the vector of magnetic flux density, that means the angle will be equal 90. Therefore, the sine 90 equal 1. In this case, the maximum magnitude obtained from this case, that means then the maximum magnetic force is created by relationship the magnetic force equal charge, velocity, magnetic flux density multiply the sine angle. Angle in this case equal 19. In this case, sine 19 equal 1. In this case, we obtain the maximum magnetic force. How can one differentiate in practice whether an electric field or a magnetic field exists in a certain space using charged particle? This ministry 1916, the first round, we throw the charged particle in a perpendicular direction to this field. If the particle moves in direction parallel to the field lines, that means is electric field in this case. But because the electric force in parallel direction to the lines of the electric field, if it moves in a circular path, that means the magnetic field, because the magnetic force is perpendicular to the velocity vector and perpendicular to the magnetic flux density vector. There are some notice is very important. The direction of magnetic field outside from the paper by represented by dot from this figure. But when the direction of magnetic field inside the paper, we represent by this figure by cross. we can determine the direction of the magnetic force when the magnetic field outside the paper, represented by that point or dot from this figure, in this case, when applying or using the right hand rule, in this case, from this using the right hand rule, the force represents the direction of magnetic force down in this figure from the velocity when putting the right hand from the direction of velocity and rotate the fingers towards the magnetic flux density. The thumb represents the direction of magnetic force, but down direction. So let's see the figure. But when the magnetic flux density inside the paper represented by sign cross, in this case when using the right hand rule, putting the hand of the direction of velocity and rotate the fingers towards the magnetic flux density vector, the thumb towards the up the direction will represent the magnetic force. Thank you, my student. I hope to meet you in a new lecture. Thank you. Goodbye.